Hey, we are live from Berlin. This is the Facebook Innovation Hub here, where we have demos of some of the technology and science research that we're doing that we think are going to contribute to the world in pretty big ways over the next 10 years. So come on out. We'll walk through this very quickly, and then what we're going to do is we're going to go up there, we're going to have a fireside chat with the director of Facebook's AI research, a guy named Jan LeCun, who has been foundational in building up all of AI research and deep learning. So we're walking through these different zones. This is Oculus behind me. We've talked a lot about virtual reality this week, so I'm not going to stop in there, but that's a place where people can go and can see, put on their the headset quickly, and get a sense of what an environment looks like in VR, where you basically can look around and be transported to a completely different place. It's one of my favorite parts of that demo is you can play ping pong in virtual reality with someone in a different place, and you can change the rules of physics. So you can actually play normally, or you can make it as if you're playing underwater or in zero gravity. It's pretty crazy. We'll do that another time, but come in here for a second. So this is the AI area of the hub, where we talk about and show some examples of some of the image recognition and voice understanding technology that we have. So check this out. So here you can basically tap on a photo, and you can ask it questions about what's going on in the photo. So what's in the dog's mouth? That didn't work. What is in the dog's mouth? And well, let's try that one more time. This is not, you know, there's a rule that live demos never work, so we'll give it a third chance. What is in the dog's mouth? All right, there you go. And I got it. It's a frisbee. You can we can check out a different one here. What are these animals? There you go. You got that they're zebras. What country was this taken in? Who took it? What country was this photo taken in? What country is this photo in? All right. As you can see, we have some work to do on that, but it kind of it shows you an interesting example of putting together. Being able to understand the photos, which it clearly could. I mean, it understood that those were zebras and things, and being able to understand voice. Part of the challenge is actually, we're in Berlin right now, and it is actually hailing and snowing. So hold on, don't go away yet. I went for a run this morning when I first got here, and I haven't run through the snow in 20 years, but the hail is kind of getting in the way of some of the sound. Here, let's take a look at this internet.org area for a second. If you pen up, this is a very small model of the Aquila solar-powered plane that can fly around and beam down internet connectivity to different communities around the world. And here, come in here for a second. This is kind of cool. So you can get a sense of how big this solar-powered plane is. It's about as wide as a 747, right? So a huge airplane. It weighs about as much as a normal small-sized car. So you can see they're propeller bays, and they're super light. I mean, check this out. You can kind of lift this up. This is a propeller bay, and here's actually the propeller. And it needs to be really light because it has these solar panels on the wings. But based on that solar power that's getting from the wings, it needs to be able to stay in the air for 3 to 6 months at a time, beaming down connectivity. So this is a pretty cool thing that we're working on. And we're doing test flights of the prototype design basically every week now as we get towards rolling out and actually connecting people with a full-size version, which hopefully will be sometime soon. So let's keep going, and we'll get over to the fireside chat. All right. Here there's a zone in here where we talk about some of the infrastructure projects at Facebook. My favorite thing about here that I think is pretty interesting that most people probably wouldn't guess is if you asked how much power do you think it takes to run all the servers that deliver Facebook in 1 year for you? it turns out that the amount of power that's required for all of the Facebook infrastructure to deliver Facebook for you for a year is less than the energy that it takes to make one cup of coffee, which is pretty crazy. We focus a lot on efficiency because we're serving a community of 1.5 billion people, and if we didn't do that efficiently, then we'd be using a lot of energy, and we want to make sure that we do that well and efficiently and responsibly. So, all right, let's keep going and let's go up and do this fireside chat. All right, here we go. We're about to go live on stage. This is Jan, the guy I was talking about a second ago. He's the director of Facebook's AI research, which we have a bunch of different centers around the world. In Menlo Park, where our headquarters are, in New York, and Paris and London. So, you want to go do this? Seattle as well. All right, Seattle too. Sorry, I didn't mean to miss that. All right, should we go do this? All right. How's it going?
Thanks for having me.
All right. Hey.
So, welcome everyone. My name is Martin Ott. I'm the Managing Director of the Northern Central Eastern Europe here at Facebook. And I'm really proud to be hosting the Innovation Hub here in Germany, particularly in Berlin. I'm even more excited to be hosting a fireside chat with two of the most inspiring people of our times, as I think, to be talking about the future and about innovation. So, please give a very warm welcome to Mark Zuckerberg, founder and CEO of Facebook, and Jan LeBlanc, our AI director. Mark, yeah, it's so great to have you here in Berlin. Let me start with Mark. People know Facebook, the social network. It clearly, there's so much more about this as we see here today. Can you help us understand how everything we see here today relates to Facebook? How are you thinking about it?
Sure. First, it's great to be in Berlin. This is one of my favorite cities in the world, and I was able to go for a run this morning. It's my first time running through snow in 20 years. But it was great. We got to go through a bunch of the awesome monuments and parts of the city. So it's great to be here and visiting with developers and a lot of different folks who make this ecosystem great. So for what you're seeing here, Facebook is a technology company, right? And I think a lot of people think about what we do as media, right? Because the main product that most people use is Newsfeed, right? You open up your app and you look through different content, and it's photos and videos and news and different things you think about as media. But the reality is that we're not a content company, we're not making that. We're a technology company which is building this really big infrastructure around the world to be able to support a community of more than 1.5 billion people every day, sharing whatever they want in any different format with any group of people, right? So text, photos, videos, in the future, whole scenes through 360 videos and VR, within a set of people, right? So one-on-one type messages, small groups, with all your friends at once, public. And in order to do that, it's really an infrastructure and a technology problem. And that's our DNA as a company, is solving those kind of technology problems. Now, when we got started, I started off in my dorm room in college, and I just started throwing together this initial website. It was very simple in the beginning. And fast forward 12 years, and now we're kind of this big company that has the ability, and I believe too, the responsibility to take on problems for the world that are going to take a long time to solve, right? That might take 5, 10, 15 years to be able to make big dents in. So what we're trying to highlight here are 3 of the areas that we've really invested in a lot. So one is connectivity. We think it's really important that today there's only 3 billion people in the world who have access to the internet. So there are 4 billion people who don't. We think that that's a really big issue because the internet is a great way to deliver educational information, health information, financial services, and communication tools too. And
right now, we just think that that's not a thing that's happening fast enough. And there's all this new technology that needs to get built there. So that's one of the areas. The second area is artificial intelligence. And that I think is going to be the big focus for what we're going to talk about today. So I'll go into the least detail there up front. But this is, I think, one of the most fertile areas for research. It's happening all over the world in different universities and companies. There's great research. This is an area where the German community has historically really been leaders. Some of the work in AI research has really been going on for decades. And we just think that this is an area, whether it's making sense of a lot of the data and the content that people want to share, helping to solve health issues, whether that's trying to diagnose diseases or drive cars more safely. These are all going to be things that AI can really advance in the world over the next 5, 10, 15 years. We're excited to work on that. And the third area is really, what are going to be the next computing platforms? So we think about virtual and augmented reality as, every 10 or 15 years, there's a new basic computing platform that comes around. There's the PC, and there's the web on top of that, and then there's mobile. And that's not the end of the line, right? There's going to be more. And what we see is that each one gets to be more powerful and more natural and more immersive. So we get the tools to share, not just simple text, which is what most people did 10 years ago, or photos, which now everyone can do with their smartphone. We're getting into an era where people are sharing more and more videos, but we really think that in the future, a lot of how we experience and share our experiences are going to be these full scenes, right? And that, so you'll be able to capture something with a 360 camera, and just be able to upload that and share that with whoever you want, and you'll be able to do it live and be able to really feel like you're there with people who are halfway across the world. And that, I think, is going to be pretty magical, but that also has a lot of research problems that we really need to make a lot of progress on before we can deliver on that promise. So those are the three areas that I think we're focused on in this hub. And when you think about what Facebook is going to be over the next 10 years, if we deliver on this promise of being a technology company that's not just working on technology and products for today, but also research for the future, I think you'll just see big advances in all these areas.
Well, very impressive to look at the areas of innovation. Let me, before we go into AI, just stop for a bit on connectivity that you touched upon, right? I've seen, building a plane. Facebook is building a plane. What is this all about? Help me understand what Facebook has to do with the giant airplane.
So there are a bunch of different reasons why the 4 billion people who are not on the internet are not connected. Some of it is that people have access to networks, but they can't afford to use them. So some of the challenge that we need to do there is just taking down the cost of serving the internet to folks, and that's a lot of the efficiency work that we do. But what we also see is that there are a bunch of areas in the world, covering about 1 billion people, for whom there's no internet infrastructure there today. So even if they had a phone and they could pay for the internet, there just would be no signal for them to get. And the reason for that is pretty simple. These tend to be rural and very sparse areas, and if there's not enough revenue or profit to be made by the telecom community in building out the infrastructure to serve those people, then they can't do it. Right? If it costs more to build out the network to reach people, then you can recoup, and it's not sustainable to do that. So there need to be some pretty fundamental technology advances that make it so that these telecom folks can provide and expand their network to new places at lower cost. So we're trying to create ideas like these solar-powered planes. And the idea is it's this basically a wing with a radio. And you have solar panels on the wings. It can stay in the air for 3 or 6 months at a time, and you tell it where you want it to go, say an island, one of the more than 10,000 islands in Indonesia where it's tough to string fiber to, or to a community in the Amazon rainforest where it's tough to get traditional infrastructure there. And you just tell it to hang out up there, and it can fly up there and beam internet to the folks, and using a lot of the same infrastructure that powers the rest of the grid that we have. So there's a need for this. We're not really doing this as a business. Our goal is to make this an open technology where we're going to work with the mobile operator community and governments around the world to use this to provide access to people who the existing infrastructure doesn't extend to.
Impressive. Now let's come to the area of AI, right? So that's, as you mentioned, one of the next big areas of innovation that you mentioned. What is AI, and how does it relate to Facebook?
How do you define AI? I mean, I'll go with my answer after, but I want to hear another answer.
Well, it's a moving target. You know, it's everything that we can solve with computers. We don't consider AI an AI problem anymore. And so now you wouldn't consider, you know, a program playing chess AI anymore. So as soon as we solve a problem, it's not AI. So it's a little difficult to define it, but generally,
to be a researcher in the field.
As soon as you figure something out, it's no longer a part of the field anymore.
exactly. You can linger on it. So, you know, generally we see AI as the set of abilities that we traditionally attribute to humans or certain animals. So the ability to learn. So learning is an integral part of intelligence, and we cannot really dissociate the two anymore. Any animal that has a brain can learn, essentially. And so one of the things we focus on in our research at Facebook is machine learning, because that's really the key to building more intelligent machines. So learning is a big part of it. And then there is the ability of the machine to learn by experience, just observing the world, acquiring new skills, and getting better at skills that it already has, being able to reason, plan, and remember things. That's it's kind of a fuzzy definition, but that's pretty much all we work on.
How does it relate to Facebook?
Well, you know, so much of what you do on Facebook, you know, you open up your app, you open up Newsfeed, and there are thousands of things that are going on in the world, and we need to figure out what are going to be the most interesting. Right? That's an AI problem. You search for someone, and you know, you search for your friend David, right? And there are lots of different Davids in the world. You're not connected to that one yet. Which one is the right person that you're looking for? That's an AI problem. You know, you want to send a voice clip in Messenger to a friend and then have it be transcribed because you know, they might be in a loud place where they can't listen to it. That's an AI problem. These are anything that has to do with ranking, you know, whether it's newsfeed or search or suggesting people that you would want to connect to or filtering out bad and abusive content in the system. These are all problems of basic intelligence in the system.
And you spoke before about AI and the impact you're trying to make on the world. So clearly, artificial intelligence has a much wider impact on the world as well. So how do you see that? Where's AI coming into play, and how do you see that playing out over the years to come?
Well, I'll take my cut at this, and then let my much more esteemed colleague to my left tell me all the ways that I'm wrong. So, you know, right now there are really two parts of intelligence or artificial intelligence where there's research being done. There's a discipline called supervised learning, and there's a discipline called unsupervised learning. And you can think of supervised learning as pattern recognition. So it's like you are reading to a child and pointing out everything you see. Okay, that's a bird, that's a dog, that's a duck. And you kind of point it out enough times and they can start to recognize the patterns of what's going on. Most of what we think of as AI today is pattern recognition and unsupervised learning. And it turns out that you can really do a lot of amazing stuff with just basic pattern recognition. So you can not only translate pretty well between almost any two languages in the world, recognize speech pretty well. We're now able to, by looking at radar for cars that are driving and images of streets, be able to have cars brake in front of pedestrians and drive much more safely than people can. We now are getting to a point where you can take a picture of a potential skin tumor and have an advanced pattern recognition AI system be able to detect whether that's skin cancer at the level of the best doctors in the world, right? So those are pretty cool things to be able to do, to be able to put that power in everyone's hands, right? Make every doctor as good as the best doctor in the world at diagnosing skin cancer, make it so that everyone can drive better. The reality is, though, that's all just kind of supervised learning and pattern recognition. The rest of AI, unsupervised learning, which is actually most of how people learn, is not people telling us what things are, right? It's basically being able to constantly have a model of the world in your head and using that to predict what is going to happen in the world next and how, if you take certain actions, how they'll be influenced or how that'll influence the world. And the reality is that we know, is it fair to say basically nothing about how that works, or very little, and or decades off probably from really fully understanding that? So, it's this interesting dualism in AI right now, where on the pattern recognition side of things, which is actually just kind of one really neat trick that we can apply to a lot of different domains, we're making a tremendous amount of progress. But when it actually comes to understanding and being able to implement the way that people think about things, we are quite far off from being able to build systems that can learn in one area and apply those lessons to other areas. How did I do?
Yeah, totally. I could not say it better myself. Yeah, the unsupervised learning is really a very active topic of research, whereas we are at the level, this is a scientific question. It's not really a technological question we're trying to solve. We're trying to figure out how to formulate a problem, figure out the right math that's appropriate for it. And so it's an issue that really is within the sort of fundamental research question. But we know it's big obstacles to making machines more intelligent, and that's what we're working on, even though it might take a number of years or decades. We see this as sort of big mountains to get through for going to the next step. What that will allow us to do perhaps is give machines what we call common sense. So if I say, Mark picks up his glass and walks out of the room, which I hope you're not going to think that.
Don't make me angry.
If you close your eye and I say this sentence, there's a lot of things that you know have to happen. Mark is probably going to have to stand up. Despite his superpowers, he's probably not going to fly across the room, he's probably going to walk. A lot of those things you can infer from just those few words, and it's because you know how the world works. And so unsupervised learning, this common sense, is what we require by just living in the world. And we don't really know how to get machines to learn this kind of stuff. So one angle that we're taking is this idea of predictive learning. So if you're able to predict how the world is going to look, if you do a particular action, if you just wait, if you just observe, then probably a good idea of how the world works. If you move your head 10 centimeters to the left, you know that the objects in front are going to move in a certain way because you know that the world is three-dimensional. You weren't born with this. You learned this when you were a baby. You learn when you're a baby that if I hide my face is still there. Well, that's why peekaboo is so funny for babies, because they kind of don't really know it was still there, and so when you do this, they laugh. So those kind of things you learn when you're a baby, and we don't really have good ways to get machines to do this today. And that's one of the things we're working on. Of course, we're also working on much more short-term applied things that have to do with supervised learning for language understanding, for translation, for recognizing images, for figuring out what a piece of content, a post or a picture or video contains, so that we can match it with people's interests. So one of our friends, likes sailing, for example, posts a picture of a sailboat, and we happen to know that we like sailboats, so we show you that picture. Perhaps you don't like cats that much, so if there's a picture of a cat, we don't show it to you. Things like that.
And it's worth calling out, Jan is too modest to say this, but in the dichotomy that I just talked about in terms of supervised and unsupervised learning, a lot of the big recent advances in supervised learning come from a principle called deep learning that a lot of you guys may have heard about. And Jan and a few other people back in the 90s, right, early 90s, really pioneered this, and it's kind of taken a while for the industry to catch up and implement this in all of the different systems that now are rolled out. But good voice recognition systems and image recognition systems and all these things now have gotten a lot better in the recent years because of this deep learning research that was done. And now we're spending most of our time on unsupervised learning, which is the big unsolved part of it.
I have that picture, and it seems like a huge problem still to solve, right? And I have the picture in my head from, maybe from the movie, someone sitting either in Alaska or Siberia and coming up with that brilliant idea. Yet I know, you're actually working with the global community and the community here in Europe very closely together. Why is Europe such a hotbed for AI at the moment? And what are we doing with the community?
Well, you're the European.
Well, so research is really kind of a global community. People the way science progresses is when scientists exchange ideas and build on top of each other's ideas. And so the bigger the community, the more smarter people get involved in a particular topic, the faster it advances. So that's one of the reasons why at Facebook AI Research we do open research. We publish pretty much everything we do. We release a lot of our code in open source. We have lots of collaborations with more than a dozen different university groups. And so we're very open about what we do. We even collaborate with our friends at DeepMind and Google for certain platform issues and Twitter and other companies. Because we think that we need to make, again, what I said, it's a question of fundamental research really, very much upstream of issues and products. And so we need to kind of build a basic science behind it before we can build technology around it. And so we're very open about research. And there is sort of a very interesting culture of research and science in Europe. Every country has its own specialty within the realm of machine learning. So there's a lot of deep learning going on in Canada. There's a lot of what's called kernel-based method research going on in Germany. Very traditionally, very sort of pioneering work in this area at the Max Planck Institute and Technical University of Berlin. There's a bunch of really talented people here from TU Berlin. And in various other cases, in Britain, there is a lot of work on what's called Bayesian methods. And so the combination of all those techniques is very interesting. And in France, there is a long tradition of work in applied mathematics. And so there's a lot of need for theoretical work that relates to this, and the French seems to be very interested in this kind of stuff. So when you make all those ideas collide together, that's when interesting things happen.
One of the interesting things, though, is that there's a very long tradition of AI research across Europe, and this is one of the areas where we're a pretty centralized company in that we have offices all over the world, but our headquarters is in California, and a lot of the development that we do for a lot of our products are in a smaller number of offices. But when we sat down and started talking about how to create a world-class AI research group that could push the world forward over a 10-year period, it was very clear from the beginning that we couldn't do this without a very significant part of that work being done across Europe. And we've already started, one of the major hubs of the research is in Paris. And what we found is that in some of the other countries, the folks are kind of more centralized into one city. In Germany, the folks who are doing good AI research are kind of spread throughout the universities throughout the whole country. So one of the things that we're very excited about is rolling out a program, which I think we're going to get to in a second.
Tell us about it, folks.
To push that forward. So all right, now I think is so we're going to talk about that now. So we're going to roll out this program where we work with and empower folks who are doing AI research across Europe and starting here in Germany by giving folks who are doing AI research access to 200 GPUs, right? So basically that's the way that it's basically the processing unit that people who are doing serious AI research use instead of the traditional CPUs for most services that you're going to run. And so we're starting here, where the first one that we're going to do is going to be 32 GPUs to a lab that's doing AI research right here at the TU. And I don't know if you want to talk more about what specifically they're doing, but this is the type of stuff that one of the reasons why some of the AI research is happening out of companies instead of universities is because companies have often more resources to build up this really big infrastructure. So you have a lot of the smartest people in academic environments, but a lot of the infrastructure is in corporate environments. And we just think that we're going to be able to unlock a lot of progress if we can contribute back to the university ecosystem the type of infrastructure that we're using to do our research at Facebook. And that's what we're doing here.
So one of the reasons why, so Mark was talking before about the emergence of deep learning, which is sort of a new set of techniques that has really sort of renewed the interest in AI in recent years. And the reason why it didn't happen before, even though the techniques were around in the 90s, is that is the availability of very powerful computers based on those GPUs that I was just talking about, as well as the availability of large data sets. That only happened in the last 5 years or so. So that's why you're hearing about AI now, not 20 years ago. It's because of the conjunction of those new techniques that have been around for a while but have been refined, powerful computers, and the availability of large data sets. Every AI research, deep learning in particular now, uses those GPU machines. So these are boxes about this big, and we can stack a number of cards in there. Those are the same cards that are designed for gaming, essentially for computer graphics. It turns out the underlying computation that takes place in them is basically very, very fast numerical computation, multiplication and addition. That's precisely what we need for deep learning, for AI research. And so each of those cards.
The applications, for example, today, is that some of the research institutions would be doing research on today.
Okay, so this is what powers all the research we do at Facebook, which a lot of other people in the industry as well. But if you can think of other research that goes on in academia for this kind of using this kind of infrastructure, would be research in medical imaging, interpreting medical images to detect tumors, for example. It turns out those systems can interpret 3D images much better than humans can, because we're limited by our eyes, that can only see essentially screen or display technology. And those systems, we can feed an entire volumetric image to them, and so they have a much better picture of what a tumor is supposed to look like, so we can train them to detect that better. This is making very, very fast progress. And in fact, some of that work is taking place at TU Berlin in the Classical Doppler's laboratory. So we're giving 4 of those boxes, each with 8 GPUs, to Classical Doppler's lab. And they are doing work in medical imaging, in something called computational chemistry, which means essentially using machine learning to sort of predict how chemical compounds will interact with each other. This is very important for things like drug design. So, 10 years from now, the new drugs will basically be designed by computers, and the properties of those drugs will be predicted by machine learning systems. And so Klaus is doing really interesting work in this area. Another thing he's working on, which is the reason he's not here today in this room, is because he's at a conference in Korea on what's called brain-computer interface. So this is the problem you have to do to interpret signals from the brain or from the muscles to be able to control a prosthesis. So, for example, you had an accident, you're paralyzed, or you lost a limb for some reason. We'd like to be able to build prostheses that can be controlled directly by the brain or by muscle currents. But those signals are extremely noisy, and you need an intelligent system basically to interpret them. Or you need to, robotic leg, for example, to figure out really if you are running, if you're walking, and things like that. That can, keeps you straight up. So those are really, interesting research projects that may have a huge impact on people's lives in the future. There's a lot of interesting research also in Germany going on in self-driving cars. And when you put together the fact that 10 years from now, your car will drive itself better than you can, and when you put together the idea that computers will be able to interpret medical images better than most doctors, lives are going to be saved by AI. And the techniques that we're developing will help with this. So okay, we're going to work on this ourselves, but we're going to collaborate with people and so enable them to make this progress in universities.
So, you'll see some Germans that are still skeptical because we always think we're the best in driving cars. But it's really nice to see the commitment really also for the local research community. Because we don't have much time left, I just want to, one more question, Mark, for you. There's been a lot of discussions recently about virtual reality, right? And please share with us, why Facebook is investing in virtual reality and how you think about that.
Sure. So our mission is to give everyone the power to express, anything that they're thinking about or experiencing and want to share in the world. And one of the awesome things about technological progress is that as time goes on, we see that everyone is getting the power to share what they care about in richer and richer media formats. So if you go back like 10 years, most of what you would see on the internet is text, right? And that's most of what people type and share. Over the last 5 years or so, most of it has been photos. We all have smartphones, we can take photos. We're now getting into a period where most of it is going to be video, and that's a pretty big shift as well in terms of how we're sharing the moments that we care about and all that. But that's not the end of the line, right? I mean, just because all we have today are TV and photos and text doesn't mean that in the future you shouldn't be able to capture a whole room or a whole scene all at once and be able to, either by putting on a headset or using some other technology, really feel like you're there with the person. Whether it's something that they captured earlier and just put online, or something that they're broadcasting live. So one of the things that I've talked about a bunch is how when my daughter takes her first steps, how I want to be able to capture that. And I think that there's this funny history where when I took my first steps, my parents wrote the date down in a baby book with a pen, right, a text, right? That's the old school way. Then when my cousin's child took her first steps, she took a picture with her camera. And when my older sister, when her son took his first step, she took a video on her smartphone. But when my daughter does, I hope that we have a 360 camera that can capture the whole scene, right? So that way, even if my parents aren't there to experience it or my family isn't there, I can either send that to them afterwards, or I probably won't be real time enough to be able to stream it to them live. But they'll be able to either put on a headset or get what I sent them in a message and be able to feel like they're really there and experiencing that and be able to relive that. And I think that's going to be pretty profound, right? So not only being able to capture real things in a much more visceral way, but be able to construct different things that wouldn't be possible. So one of our fun experiments that we have right now is there's video, but there's also these gaming environments, right? So there's these 3D environments that you can construct. And so last week we had the president of Indonesia visited Facebook, and I gave him the latest tour and demo of Oculus and what we were doing with VR. So we put on the headset, and we're in different rooms, and we start playing ping pong, right? And there's this table, and you can pick up the ping pong paddle and play it. And it's like, all right, this is cool, but we can kind of do this with a normal table. So when does this actually get interesting? And they're like, all right, this is where it gets interesting. Let's dial up and down gravity, right? So now we can change the rules of physics and play something really crazy that we could not otherwise do. And so first it's like, all right, let's go to zero gravity and play ping pong as if we're in space, all right? It's like, all right, that's pretty cool. So we're hitting the ball. It's like, all right, don't hit it too hard because there's no gravity, it's gone, right? And the good news is in virtual reality, there are always more balls. But still, it's not very fun if you don't have a rally. So then I'm like, all right, fine, well, we're getting the hang of zero gravity ping pong. Let's go anti-gravity, right? So now the rules of physics are such that by default, everything floats up. So now instead of hitting it up, you actually have to hit it down to keep it in your zone, or else it's floating away. And it's like, all right, that's pretty cool. Right? This is actually a picture of the kind of the zone that we were in. It's still pretty rough and early, but it's enough that you can really feel like you're in this zone and experiencing this. So I think that this is going to be pretty amazing. The mission that our virtual reality team has is to give people the power to experience anything. Right? So whether that's a real thing that's happening halfway across the world that you just couldn't be there for, or something that because of the way the world is set up is very difficult or impossible to build, but you can experience this way. I think that's going to be pretty profound for spreading a lot of different experiences and giving people the tools to express everything that they care about, which at the end of the day is Facebook's mission.
So one last question. How do you see Facebook in 2025? So 10 years out from now?
Well, hopefully we'll have made progress on a lot of the stuff we talked about today. Right? If you talk about connectivity, AI, and virtual and augmented reality, connectivity, 3 billion people are connected today, 7 billion people in the world. I think at the current trend, if there were no real new breakthrough technology, we're probably on trajectory to maybe connect another billion people. So we'll still be here in 2020 or a little bit afterwards, and there'll be 4 billion people in the world connected instead of 3, but still almost half the people in the world will not have the opportunities that the internet brings. So we hope to really bend that curve, right? But through deploying these technologies and working in partnerships with all these folks, I don't know if we're going to get all 7 billion, but maybe 5, right? Or closer to 6. In AI, I think the big question is unsupervised learning. right? We will continue making progress on all of the different problems that we're working on today. Better voice recognition. I did a demo earlier that didn't work, so that'll work in 10 years. Hopefully it'll work sooner. But I do think we'll have some breakthroughs that we know are possible now will hopefully be rolled out. So, self-driving cars, whether it's fully self-driving cars, it'll just be more cars will drive themselves more of the time, or they'll brake more of the time when they know that there's about to be an issue. You'll have systems that can help doctors diagnose diseases. All these kinds of things will hopefully be pretty far in circulation in the world and save a lot of people's lives. And for virtual and augmented reality, there's some real science questions that still need to get solved to create the experience that we all want, right? Which is kind of like the glasses that we all wear on a day-to-day basis, and not like this big set of goggles. But we're at the beginning of that industry. This year we're going to ship the consumer product for the PC high-powered version. We've already shipped with Samsung the mobile version, and a lot of people are using it. We announced just this week that there have already been 1 million hours of 360 video content consumed in that Gear VR product that we ship that's mobile VR. So that industry is at the start of becoming something real, and I think it's going to be really exciting to check in 10 years from now and see where that's going. But remember, these things take a while, right? From the time that the first and earliest smartphones came on the market to getting to the point where smartphones were about to be the main computing device was about 10 years, right? 2003 was, I think, when BlackBerry first launched its product in Montreal, and there weren't a billion smartphones in the world until about 2013. So this is, I think, going to be pretty similar in terms of needing at least 10 years to really become a very mainstream big thing. But we're committed to this. I think if we have the resources to be able to invest and do these investments across the whole world to bring the research community into this, and I think that this can make a big difference for giving everyone the power to share what they care about and helping everyone sharing the opportunities of the internet. So thank you.
Absolutely. Thank you. So time flies. I'm talking to you too. I know you have to rush, but thank you so much for sharing your thoughts. Everyone else, please don't rush out yet because all the exciting stuff that we talked about today, you can actually feel and get a feeling for the innovation on.
Awesome.
A warm thank you to Mark Zuckerberg and Tony Cohen. Thank you.